So in this class, we are going to make a very interesting experiment. We're going to check if stocks will recover. So what we're going to do is to imagine that you wake up every morning and you are going to look for all the stocks in the stock market that have a huge change, like fall in 10% or 20% or go up by 10%. And then we're going to enter the position expecting mean reversion, which means expecting the stock to recover to the other side. And we're going to see if it actually happens or not. So looking at this curve, let's see, we have 3 days here, and the barrier you see in the middle is the night. Okay, and let's say during the night between 2 days we have news, right? Things happening. So what it means is that the close price of one day is different than the open price the day after. So if the close price of this day, the first day, is 100, the open price of the second day could be 50, right? And also you remember for each day we have a open price, low price, high price, and close price, right? For each day. So we are looking for all the days where the open price of day 2 or a certain day minus the close price of the previous day will be equal or larger than 10%, plus minus. So we are looking for all the cases where the stock fall in 10% or went up by 10% compared with the close price on the day before. Once we have those days, we also look for recovery. We want to ask if this happen when or if the stock recover at least 1% back to the other side. So you can see H1 and H2, you see the blue points here. What we want to ask is, after we enter this position, in the next few days, if H1 or H2 or H3, which means the highest price of each of the next 3 days, was larger than the open price, because this is when we enter this position, right? So you can see here that if we enter the position here on O and the open and H1, we had a change up, the stock went up, the higher price of that day was 1% higher than the open price, right? So we want to check if the high price of the one of the next 3 days, H1, H2, H3, was larger, at least at 1% above the open price where we enter this position. This is our test. So looking n days into the future, n could be any number between 1 to 10, for example, we are looking if the maximum of the high price of each day of the next few days, here H1, H2, H3, which is n equals 3, is larger than the open price multiplied by 1.01, which means 1%. We want to check if the highest price in the next few days was larger than the open price where entered the position. So let's see how this looks in code. If you remember in the first class, we programmed this module API, which allow us to get stocks data from the internet. And we learned how to do this with Y Finance, which was a free API. And we are currently working with Polygon. We learned how to get normal stock by giving it ticker, dates, and interval. But now we want to write a different function which allow us to get the entire stock data information for one day. So let's go ahead and check the documentation in Polygon. Under stocks, there is an endpoint called grouped daily. This is how the URL is going to look like, and this endpoint going to provide us the daily open, high, low, and close for the entire stock market for a certain date. So let's say we will pick a date, and we will tell it if it's adjusted or not, it's true, and if we include over-the-counter stocks, which will be false because we are not interested in them. This is how this is the URL we need to create in order to provide for the API. And as you can see, the only thing here that we need to, the variable here is the date. So, and the other thing we need to provide is the API key, which of course you can get in Polygon. So the response of this API is going to be a dictionary, and in particular we are interested about the results key in this dictionary. And the results key is a list of dictionaries where each dictionary represent a single ticker, the ticker for that day. And the ticker for that day, we are going to get C, close price, H, high, low, etc., and open prices. And here you can see T is the time, is the date, uh, which is given to us by milliseconds. We will turn it to be a date object, of course, and V is the volume. What we're gonna do, we're gonna turn this results key into a data frame. So let's see how this function work. So this function gets the date as an argument. First, we have the polygon key that you can get from the website, and then we take the date and object and turn it into a string in this format, because that's what the API required from us. The next thing is we create the endpoint URL, which look like this, and we give it the date, right, as a string at the end, the date in which we're interested to get data for. Next, the meta, which is the end of this URL. At the end of it, we provide the polygon key because that's required for each API call. So next we, as you see, base plus meta, right? And we get the URL, and then we use the request function that we program in class 1 to make a normal HTTP request. Once we have the result, we first ask if results key is inside R in our response, because on weekends, for example, you will have no response from the API. So we have results, which is the results key, and we create a data frame from these results. As you can see here, we create an empty data frame where results will be used to create it. But we want to change the columns names because the polygon names doesn't fit us. So to do that, first we create a dictionary of all the names that we want to change. So as you can see here, you see O will be called open, a T will be called date, etc. And this dictionary will be used to change the name. So we are doing here data frame rename, and we give it the columns, we give it the dictionary name that we define here. So the name of the columns will be our own names. Next, as you remember, we said that the date that the polygon gives us is just a number in milliseconds, but we want to see a date, a clear date. So we are going to turn the date column into a normal date object by using this PD to date time. And next, we're going to take this date column and we want it to look like this. We want it to have a year, month, and date. So we change the format to take only the date element without the time from this column. And we return this data frame. So let's call this function. Here we are giving it a date as a string. We turn the date into object, and then we call the function get group daily with the date, and we print the results. Let's run this, see how it looks. So we got here the data frame, and you see here more than 10,000 results. So just to clarify, those are 10,000 stickers for a single day. Let's scroll up. So this is our columns. We have a ticker, volume, open, close, high, low, and date, right? And those are the prices for a single date. As you can see, all the dates here are the same because we ask data for one day. So we get 10,000 tickers data for this one particular date. Okay, so we ask for data only for one date, but we want to now ask data for a period of time. So we write this function called get here, and let's see how it works. So first we import the API that we just showed, and pandas and numpy. We don't have to expand on this. And next we import a library called OS, which allows us to manipulate local files. We will see why we need it later. we will define here two dates, which is the period of time that we are interested to get data for. And it's just a few months, but it takes time to read all this data. Next, we turn it into objects as usual, and current date is just a variable that will get the first date in this period. And next, we are defining here an empty data frame to contain all the data that we are going to read. Here we have a while loop, which says current date smaller or equal to date 2. Date 2 is the last date of the period, right? And the current date is the first date of the period. This is how we start the loop. So we start from date 1 and we ask as long as this date equal the last date. And each iteration of this loop, as you can see, current date will be incremented by 1, time delta 1. So we start by date 1 and we add 1 day every day as long as we are smaller than the last date of this period. So what we're going to do here is first we take the date, which is current date dot date, which means take only the date element without the time, right? Once we have the date, we want to call the group daily function that we just showed, and we provided the date and get the data frame, which means all the tickers for that date. Okay, for this date we get all the tickers as we showed, and we ask if this data frame is not known, because on weekends we might not get data. If it's not known, we take this empty data frame that we have and we use the concat function, which means take the new data frame that we just received, okay, and add it to the empty data frame that we have already. So each time we get a new data frame for that particular day and we add it to the current data frame. This way we are going to fill our data frame with each day's tickers. So here, as you can see, we increment, of course, the current date every time by 1. So we get each date of this period. Next, we are going to save this data. So you can see data to CSV, because we don't want to read this data every time because it takes time. So once we read it one time, we are going to save it locally. We save it locally and we call it data.csv, and will be saved here under the root folder in this project. So next, we are going to ask if this data frame exists locally, if this file exists, and we're going to use the OS. OS is the library we show here that we imported, and we are going to ask if this file called data.csv already here, right? So if we already read this data, we don't have to do this. Otherwise, we will call the get function. So if this path does not exist, right, get the data. But if it exists, what we're going to do is we're going to read it. So read CSV, data CSV, which means read locally the data.csv file, okay, and put it into a data frame. So let's print this, let's run this and see what happens. So you can see here that we get loads of results, and those are just results for all the 3 or 4 months of data that we requested. And you can see here we have the ticker, volume, volume weighted, etc., and all the columns as we define them. And this is the first date of the period, right? We start, and this is the last date of the period. Cool. So once we have this data frame, let's manipulate it a little bit so we can check if our recovery strategy works or not. So we're going to add this code here. Okay, so in order to test this strategy, we have to manipulate this data frame a little bit. So we start by dropping here these 2 columns that we don't need. So it's the volume weighted column and N, which is the number of transactions. We don't need these columns for this program, so we drop them. And next, we are going to remove all the stocks that have a volume that is very low. In this case, we define 500,000, 500,000 of volume. If the volume is in any day of the year was lower than 500,000, we don't want to even consider that stock. in our backtest, so we're going to remove it. So you can see here that we create a mask, and then we use this mask in order to filter this data frame out from all the low volume stocks. The reason we do it because low volume stocks are harder to trade, and it will make everything much more easier. Okay, so next we want to find, as you remember in the sketchboard, we said that we want to find all the days where the open price was different than the previous close price, right? And there was a big change. So we want to also check that the volume when this happened, we had a certain volume. In this case, we want to ask that the volume was larger than 600,000. So we're going to create a new column here called data frame OC, which mean open to close. And first, we're going to ask if the volume was larger than the minimum volume, right? So the first condition is that all the rows where the volume is larger than 600,000, this is where we're going to calculate the change. So how we calculate the change? The change will be this formula here. So it's going to be the data frame at open divided by data frame group ticker, right? We group by ticker and take the close, shift it by 1 and calculate the percentage. So essentially what we do here is we take the open price for each day, right? And we divide by the close price. But in order to do that, we have to group the data frame by ticker because we have many tickers, right? We want for each open, take the close of the ticker that fit that close price. And of course, we shift it by 1, right? Because we want the close price of the previous day. And minus 1 multiplied by 100 is to get the result in percentage. Okay, next we're going to reset the index. We want the index to be more organized, so just for convenient. Next, remember we calculate the open to close change, right? We get the change in percent. So now we want to ask where this change was big enough, and we define big enough as change equals 10%, right? So we want to ask where was this change, where open to close was larger than the change, which is 10%. In that case, put 1 in this new column. Or in the other way, if the change was smaller than minus 10%, right? So you can see here where NP, where data frame in column OC was smaller than minus 1 multiplied by change, which means if the change was minus 10%, for example, so then put minus 1. And otherwise, we will put 0. So what we get here at the end is that the signal column will have minus 1 in case we have stock go down by 10%, we'll have 0 if no change, or 1 if it goes up by 10%. And we're going to use this signal column later for our strategy. So next, if you remember from the sketchboard, we want to check if there was a recovery, which means after we enter the position, we want to check if the recovery in this case, 3 days, was higher or lower than our position. In other words, we want to check if we make money. So let's define here data frame, the max H and minimum low. So how do we do that? We first group by ticker, right? Because we have many tickers. So we have to group the data frame by ticker. And then we take the high column. And here we use the lambda function. And the lambda function will give us X, which means this is the row. And for each row, we're going to shift it by minus recovery time, which is 3 in this case, and use the rolling function with 3. Now, why we do that? The rolling function can take the previous 3 days, okay, and calculate the maximum from the previous 3 days. But we don't want the previous 3 days. We want the next 3 days. We want to see if there is recovery in the next 3 days. So what we do here, we first shift this data frame by minus 3, right? And after we shifted by minus 3, we do the rolling. So essentially what we did here is we are looking to calculate the maximum, right, of the rolling window for the next 3 days. So we are looking for the highest price in the next 3 days. And then we do the same with the minimum, right? We shift the data frame by -3 and check the rolling of the next 3 days, and we take the minimum. Okay, so next we talk about the recovery. As you remember, we want to ask if we had a recovery of 1.01, which means 1%, as we showed in the sketchboard. So recovery up and recovery down are two new columns we are going to add here. Recovery up means that if the stock went down, for example, in 10%, we want to see if it recovers up by at least 1%. That's what we define. You can define something else. So we do that by group by ticker and then apply the lambda function. The lambda function will give us groups, right? Which in this case is tickers. So for each group of tickers, we are going to we're going to check the signal column. And we're going to check if the signal is -1 or 1, right? If we went down by 10% in this case, or we went up by 10%. So in the case that the signal was -1, which means we went down by 10%, we are going then to check here if the open price was smaller than the maximum high. So let's check it more deeply. You remember that signal -1 mean that the stock fall in 10%. So that moment when the stock fall 10%, we will enter the position with the open price, right? So what we want to check is that if recovery multiply by the open price, recovery was 1%, as you see here. So if the recovery multiplied by the open price is smaller than the maximum high, which means that in the next 3 days, the stock highest price was higher than the open price by 1%. Okay, so if it fall in 10%, the stock, and we bought it, that open price where we bought the stock is lower than the maximum price of the next 3 days by 1%, which essentially means that the stock went up by at least 1% when we entered the position. That was recovery up, which means that the stock recovered up. Here we ask the same if the stock recovered down, which means if the stock went up by 10% and we enter the position, we want to see if the open price where we enter is larger than the recovery multiplied by the lowest price of the next 3 days, which essentially means take the lowest price in the next 3 days and see if it's lower by at least 1% from the position when we enter. Here we will just filter the data frame. We will take all the rows where signal was -1 or 1. Those are the cases where we have big change in the stock. This is the data frame after we run this. So let's go over it. You can see that the basic columns that we define, ticker, volume, open, close, high, low, and date are here. But there is the new columns that we just added. So let's look at them. So the first thing we can see is OC, right? Remember that we define open to close column. And here you can see all the cases where we have a big change in the stock. So here we have -10% this day, right? And the next day we have here plus 20% up, right? Plus 10% up, -12 down. And you can see that the signal fit them. The signal is -1, -1 when it's negative change, and +1 when the change is positive. And we use it later, as you remember. And then we have the max H and the minimum low, which means the max H, for example, is the maximum price in the next 3 days, right? Here it's 7.29. So if you consider this line, we entered the position at price of 6.9, right? Because we see that there was -10%, like the stock will fall in 10%. So we bought the stock at the open price of 6.9. And then in the next 3 days, the maximum price was 7.29, which means we went up by 1%. And for this reason, the recover up is 1, right? We were able to recover because we buy it at 6.9, and in the next 3 days, the price came to be at some point 7.29, which, by the way, maybe it could go up more in the next few days, but we just wanted to check in the next 3 days if we recover by 1%. So For this reason, recovery up is 1. But as you can see, it's not always 1. Sometimes it will be 0. So let's go back to code and calculate the success rate for this strategy. So we create a column here called success, and it equals 1 or 0. So it will be 1 if one of these two columns, recovery down or recovery up, was 1, right? If we had a recovery for up or down, it will be 1, otherwise it will be 0. We use the OR operation here. So this column will be used later to calculate success. Here we just print the data frame. So next, let's calculate the success. So success, this is a variable, right? It's not a column. So success equals 100 multiplied by the length of all the rows that success was 1, right? If there was a recovery up or down, we had success 1, right? So we count all the rows where success was 1. We multiply by 100 because later we want to calculate percentage. Okay, so now we want to calculate something interesting, success down and up, which means what is the rate of success with this strategy when the stock went down, and what is the rate of success when it went up. So take all the places where all the rows where signal was -1, which means we had a negative change rate, for example, -10% down. And check if there was success recovery back up. If it happened, count all this time and divide it by the amount of time we had a negative change. So take all the times where we have -10% down and check how many of them we had a good recovery back up, right? And this will give us the rate of success recovery when stock went down. And the same do when stock went up. So for example, if stock went up by 10%, so its signal will be 1, right? And we want to ask how many times there was recovery back down at least 1%, as we showed. Here we divided by the total amount of times where we have a positive change. So print the total success rate, which is the success we just calculated before, remember? The amount of time success was 1, divided by all the cases. That's how you calculate success, right? The amount of positive results divided by the total results, right? And then success up and down, which we just showed. And the total result, how many results we had, and how many results up and how many results down. Let's just see how it looks when we run it, and we can understand it much better. Okay, so this is the results. Let's scroll up and see how the data frame look like. So essentially it's the same data frame we just saw, but here we have the important column called success, which could be 1 or 0. So as you can see, it's 1 when either of recovery up or recovery down columns are 1. If both of them are 0, recovery up and down are 0, so the success will be 0. So you can see we failed many times in this strategy. That doesn't mean we lost money though. So let's look at it. The total success rate is 68%, which is okay, not bad. And the important result here is the success up and down. Success up is 76%, success down is 59%. That means that success up means that when the stock went up, there was a recovery back down as we expected. We had a 76% chance of this to happen. But when stock went down and we wanted it to go back up by 1%, we had only 59% chance for this to happen. The total results is 405, and ups and downs show you how many times went up, how many times went down. So to summarize, this line is very important. To summarize, we can say that though the total success rate is 68, the higher success rate is 76, and that means that if every time stocks went up, we take all these positions in this table, we will have 76% chance success in this strategy. The point is that you will have to take many positions every day, because as you can see, for each date you had many stocks that went up, and if you just choose some of the stocks here like randomly, and you enter position in those stocks when they fall or when they go up, you will not get 76% chance, because you will add noise to the system, right? This 76% success is if you buy all the stocks in this list. But if you just choose randomly, you are not going to have 76% success rate, because you are essentially ruining these statistics. So we have to find ways to define which of the stocks that have the change we should take position at. Okay, this is it for this class.